All right, guys. So we're going to do the part that I did in class today. So that way, if you were absent, you can get caught up. Now, this paper will be in the classroom. So exponential functions, when we're talking about growth and decay, you've already seen the function y equals a times 1 plus r to the t, and the equation y equals a times 1, minus r to the t. Get rid of that. That was my mistake there. Okay. So now what y'all need to see is they're going to change the equation on the test for you, and it's going to look like y equals ab to the x. I can't write today. To the x. There we go. So we know from before when we were doing growth and decay that A stands for your start or your initial amount, however you want to write it. Okay, we know that X is in the same spot that T is in, and that T stood for time interval. Okay. Now, B is the only thing different, where we had for growth 1 plus the rate and for decay 1 minus the rate. So B is actually going to stand for your growth or decay factor. Okay, and what I mean by factor is they're going to actually put this all in one piece together. It's no longer going to be 1 minus r. It's already just going to be that decimal. Okay, so to find B, the factor, you have to convert your rate from a percent to a decimal. And remember, from a percent to a decimal, you have to move it 2 times. Okay, so when we're doing growth, you must add the decimal to 1. So there's an example. And when we're doing decay, you must subtract the decimal from 1. So it's always got to be 1 minus r. If you go the other way, you'll get your answers backwards. Now, something that is different that you haven't seen on the easy worksheet that we did was sometimes they'll just say that the data is doubling, which makes your rate, your factor, automatically a 2. You don't do 1 plus it or 1 minus it. You just leave that alone. If it says it's tripling, you would do 3, and that's all B is. There's no 1 plus 1 minus. Sometimes they'll say that you have a half-life, which means you would use 1/2. Now, going into this, here's what you're going to do. There it is. Okay, so a rabbit population triples every year. If I start with 4 rabbits, how many rabbits will I have in 7 years? I'm going to underline everything important. The word triples is important. 4 rabbits, 7 years. Those are my 3 important things. This is that example where I was just talking about. So you already know that your growth factor is 3. So triples, go over here to your growth factor, that means 3. Okay, since it is tripling, that means it's growing. So this is growth. And my rate, the rate was that word triple, which in other words just means 3. Okay, the initial amount, I start with 4 rabbits, and my time interval, I want to figure it out in 7 years. So now that you have this information, you're just going to plug in the formula, f of x equals ab to the x. So this is your a, the initial amount, 4. This is your b, your growth factor of 3, and this is your x, your time interval of 7. Once you have that, they want you to predict what you think it's going to be. So you're just going to type in that equation, 4 parentheses, 3 closed to the 7th. And you're going to get 8,748. Okay, you have to think about what we are talking about. We are talking about population for rabbits, so 8,748 rabbits. You got to always label real world problems. Okay, for 2, 500 is invested in a bank for 18 years. If the money made 12.5 each year, what was the value when the account was closed? Okay, so 500 is important, invested is important, 18 years is important, and 12.5 is important. Okay, starting with 500, this is what I start with, so that's my A. Okay, invested means I'm putting money into the bank, so that means I am growing. Okay, 18 years is my time interval. 12.5 is my rate, but I don't like percents, So don't forget that you have to take the decimal and move it twice, which will give you 0.125. Now, to come up with your growth factor, this is where you have to go back up to this thing right here and do the 1 plus that. So since it's growth, I'm going to do 1 plus 1.25, which will give me 1.125. And that's my growth factor. Okay, now what I'm going to have y'all do is you're going to plug in the formula and get your answer yourself. Okay, your prediction, it's talking about money, so don't forget your label. I'm also going to have you try number 3 on your own, but I want you to pull out this word depreciate and make you think what depreciate means. That's my hint to you. So you're trying those 2 on your own. Okay, now I'm going to flip to the back. So if you wanted to pause and solve those first, you can. But I'm going to flip to the back, and we're going to do 4, 5, and 6 because that's what we did in class today. Okay, the function of Evans town population can be represented by the equation f of x equals 4,210 times 1.045 to the t. Okay, I added in an extra question here. I made them tell me if it was growth or decay. The way you figure it out is you look at this decimal. If the decimal is greater than 1, it's growth. If the decimal is less than 1, it's decay. So this is growth. So I want you to just go ahead and write growth on the side. Okay, they want me to find the initial population. Well, since it's in the equation, we know that the initial population is in A's spot. The number that's in A's spot is 4,210, so that's my initial population. To find my rate, right now the growth factor is 1.045, so I need to take this 1 away, which gives me 0.045. And then I have to convert this back to a percent, so I move it 2 to the right this time. And that gives me a growth rate of 4.5%. Okay, to make a prediction for the population in 12 years, you're just going to take your equation, the original equation, don't change anything, and put it to the 12th power. Okay, so I put it in. I'm going to get my answer. There's my answer. We are talking about population. So it's Yes, we're talking about population. So population is talking about people in this situation because we're talking about a town. So first off, I'm going to go ahead and put people on here so I have my label. And then the second thing I'm going to do is look at my answer. We don't have parts of people. So we have to look at this first decimal and what is 6 going to do to 9? 6 is going to round the 9 up, but that 9 is going to make the 3 go up, and we're going to have 7,140 people. Okay. For number 5, it says in 1998, the population of humpback whales began decreasing. Ooh, that's an important word. And can be represented by the equation. Okay, so f of x equals 176,534 times 0.926 to the t. Okay, so they said decreasing, and when I look right here, this is less than 1, so this is decay. So I'm going to write decay. To find your initial, you look for the number in A's spot, and that number is 176,534. Okay, this time for your rate, you got to do it a little bit differently. You're going to take the 1 because it should be a whole number, so 1 minus 0.926 to figure out what's the missing piece. And the missing piece will be 0.074. And then you convert that to a decimal, a percent, my bad. And you get 7.4%. Okay, now to make a prediction, and this has a typo. It shouldn't say years. It should just say make a prediction for the population in 2005. Okay, we started in 1998, and we're going to 2005. I need you to figure out how many years that is, and that is 7. So you're going to take that equation up there, not change anything about it, and put it to the 7th power. So there it is, and I put it in the calculator, and I am now trying to find the population of humpback whales. So I'm going to go ahead and put whales as my label. Again, we're talking about population, so that's whole pieces. We are not going to have part of a whale, so I'm going to keep everything and then look at this 5 to figure out what to do to 3. The 5 tells me to make 3 go to 4. So I have 103,064 whales. Okay, now I want you to try 6 on your own, and I can check it. We're going to finish 7, 8, and 9 in class the next day.